Hello everyone. Let me check if the sound works. Just one second. Perfect. Okay, so the thing that we're doing here right now is coding an implementation for what's called a Cyrano protocol. Let me show you. It's a protocol for communication between the software and a fencing scoring machine. And basically I just wanted to get into the Rust development more. So I have some basic knowledge about the Rust development, but right now I would like to deepen my knowledge in this programming language, and right now that's why I'm trying to implement UDP communication and this protocol. So this way I will improve in networking and network programming. And by the way, we will have to use multithreading, or at least I implemented this protocol a few times, and I had to use multithreading in every language. Basically, I've implemented this once in C# back in the days, like 5 years ago or something, and then 2 years ago or something I implemented this in Python also. So basically what I've done so far is I've set up a basic UDP communication. It's basically just the Rust basic example for UDP communication. I implemented displaying the received message in text, and so as you can see here, I created a localhost address. I gave the 50,100 port because this is the port that the fencing scoring machine uses, and I created a socket which I bind it to this address, and I created a buffer, and that the message will fit in. Basically each character represents a byte, so that's why this is 210, because the maximum length of a message, I will get right into this later, but the max length of the message is about 210 characters, so that's why. And then I'm listening to this port basically, and receiving the buffer, which I save into this buffer variable, and then I print the number of received bytes and the raw bytes, and then I convert them to a string, and I print them as text, and then I print the number of characters in the text just to see. And now I'm trying to decompose the message, because a message right now looks like this. for example. And yeah, we have to separate each field. We have to separate the parts of the message, and then because it has like sections, and the sections are separated by this sign, and then all the information which is inside is separated by this sign. And we have a list, a table for each field that we have to store. So basically we have to decompose the message. But there are some things that make this a bit hard for us, because the message itself can come in various, so it can vary. Basically, as you see, we have to take into consideration that values are given with the natural length, that's okay. An empty value is given by two consecutive this signs, I don't know the name of the sign, and if from a position of an area to the end of the area all values are empty, they can be omitted. And I just didn't read this line, and this caused me something like this, which I will show you. For now, just I will not explain the things I've done, because I will get right into this. But the thing I saw, and I run my code, because I implemented already this decomposition algorithm here. This is for the new one. Yeah, this is, I expect 41 fields, because there has to be 41 fields, and these are all the fields. And basically now when I do cargo run and I'm trying to send a, oh my god, send a message, for example, I get an error that there are not enough fields, and this is because I didn't check the protocol enough, and in this part where it says the empty values can be omitted, I didn't check this one. So now I'm trying to implement this, and I will walk you through how I'm trying to implement this. Basically, it's just that when I'm receiving my row buffer, I will first split it into sections, and then collect the general, the right fencer data, and the left fencer data. And then if it does not have enough fields, I will fill them with zeros, with empty fields, just to make sure that every field is existent. And yeah, so basically this is what I'm doing right now. Let me quickly check top. Okay. I've just counted the fields because each fencer should have 12 fields, I think. Okay, I will quickly implement that. It should print the general data length, which is okay, and also for these basically what I'm doing right now is just diagnostics. I wanna see that how many values are in the vector for general right or left fencer. It's 15, 13, and 13, which is a bit weird. For the fencers, it should be only 12, so there's something wrong. Okay, maybe I'll also print out the sections. And then we'll see. Maybe we'll have to trim. Yeah, but let's just do that. First we will trim matches, because I think at the beginning and at the end there are these characters which make more fields than it should be. Yeah, I think now it will be okay. What? Yes, now it's 14, which is okay. That's not enough, but for the fencers it should be 12, and now it's 8 and 8. Yeah, the text is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So something is off. Yeah. Okay. Let's print out the sections. So after the section separation, we have to print out the yeah, sections. Oops. Yeah, now I know what's the problem is, because like I did here, we'll have to, if we have to check basically if the value is empty, and if the value is empty, then we should add a 0 instead of the value. And if the value is value, then we just have to write the value, of course. So I think it should come right here, also here, and also here. So now we should see for, I think we should, I don't know what we should see, but we should see 11 for the fencers. 11, yeah. Still not 11, why? We should ask our friend or something. It's interesting. I can't seem to find the problem right now, but because as you see here, okay, let's but we are printing this, so that's 1, 2, 3, 4, 5 match, yeah. This one's okay. 3 empties, 1, 2, 3, 1, 2, 3, and 1. Okay, and this is 14. 2, 3, 8, 9, 10, 11, 12, 13, 14, which is okay, but 1, 11, 12. Now this is also okay. This one. So something is off with the logic. Yeah, maybe we shouldn't trim. Oh fuck, because I'm trimming the first signs. Oh my god, it's so stupid. Now how can the what okay, so maybe we have to trim here but not here. Okay. Yeah. Yeah, we'll have to trim the first one from the beginning for the fencers. Like this. Yeah. Basically. Something like this. Just like this. Okay, because we are trying to, okay, so let me do a quick search. Can we do it like this? Like... No, okay. If we can do it like this, then no. It's okay, but what if we do it mutable? Did sections 1 and also for also for section 2 we do the same. And what's up now? Let's see. Perfect. No, not perfect. 0. Yeah, we'll also have to remove the last. Yeah, we'll also have to do this. Oh. But basically we could do it in one, I think. This is what I got from ChatGPT. Yeah. Yeah, something like and I think this should work now. Yep, perfect, 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 perfect. Yep. Right now it's perfect. We don't have the sizes, but that's okay. That's okay, because now we will have to do some things. So fill the ends of these vectors with zeros, so they have the right amount of fields in their sections, and then combine them all together to a big vector. So which will be this SP vec. So I can get all the information out of this, and use the struct I made to instantiate the struct with the data that I will get out of the vector. So let's do that. First thing is, I think, is to fill all the, so for each section we should define the constants. Basically it's just it should be 17. That should be 12 for each fencers. Yeah, okay. Yep, and right now so let me comment this out, because how do I comment it out? I thought it's okay. I will not comment this out later. So we'll have to do an if because general len is usize, but okay. Should I do this? Yeah. Okay. Now if it's not equals the general length, then yeah, okay, maybe we should do it like if it's smaller than the general length, then let's see how small is it, so how much characters are we missing, or how much fields. So let equals general length minus the general not len, it's usize, yeah, but and then because else if general.len is greater than general length, then we should return an error. Okay, maybe let's not do that right now. If it's not equals this, then we'll do something. Yeah. Let's see. So we should fill our array with enough elements. I'm just looking up how do I Yeah, so basically what we'll do is I'm not sure if our general vector is mutable. But we'll have to make it mutable, and also this one and also this one. Now we'll have to do that. We have to do general the tree size. Missing. With zeros. Okay, yeah, with zeros. And we have to do this with, do the same with right fencer data, left fencer data, left fencer data, and also left fencer data. Yep, and now it should be okay, I think. And now we should be able to create our new vector that should be like spvec. like this. Right fencer data and then left fencer data like this. And basically now we should be able to write out the length of the SPVec. But we'll see here. If we get an error, we'll see. If not, then that would be perfect. No, that feels 15. Maybe this operation, yeah, because this should be fencer field length. This also should be now we just got 5 fields. Oh my god. Okay. Something's off. Way off.